Hello, everyone. This is Rakesh Jain. I'm from IBM Research, along with my colleague Ramani, who actually initiated this project, but he's not here right now. So today we are talking about, this is all about storage provisioning. And we are doing it for a service provider, which is IBM Global Services, which is GTS. GTS is actually one of the largest service providers in the world. And what we are doing actually here is that we're trying to automate storage provisioning in GTS. Now, the way GTS works very briefly is that it can take all the infrastructure management, application management, processes, all IT management from the customer, basically outsourcing and managed services. So what happens in this case is that it is the customer who decides what infrastructure to use, what software to use, and things like that. So what we end up with is a heterogeneous set of hardware, and specifically talking about storage. You have all kinds of storage. You have EMC, VMAX, IBM, SVC, NetApp, everything. And it is such that just one customer can have a lot of different storage systems. And this is actually traditional data center, not actually in true sense cloud. So in such an environment, provisioning storage is a really difficult, is a tedious and complex process. Basically, application owner will give the requirements to the server administrator will understand it, will give it to storage administrator. The storage administrator will translate the application requirements into storage capabilities, and then it will go through a number of checks and approvals, and then it will get deployed. So it takes hours, and in some cases it takes days. So that's a problem we were trying to address. And then comes Cinder. So Cinder is basically, we have one interface for all these different storage vendors, storage providers. And we don't have to write any code for that. So basically, we got pretty nicely tested code for each storage vendor, and we can use it with one interface. On top of that, we have Horizon, which is again a single pane of glass for managing all your Cinder storage. And so if you have automation in some accounts, there is some customers, they have automation, so they can use Cinder APIs directly. And in some cases, they use some kind of portal to provision storage. And so what we call self-service here is basically we are allowing the server administrators to provision storage on demand. Now, this is not a cloud kind of environment, so it's not like pay and get the storage. This is more like within the customer environment. So we have to have some boundaries. You can't just open it all, because otherwise the server administrator will get a lot of storage in advance. So we have to have some boundaries, and that's what we do with these policies, and I will go over that. So this is basically the picture we want to get to, and we actually got to. The storage administrator will define the service catalogs and the policies, and within this framework, if you have automation, you will go through Cinder APIs. If you want to do self-service, you will use the Horizon portal. Now, service catalogs. So these are basically, if you know Cinder volume types. So service catalogs are basically the Cinder volume types. For example, you can have Platinum, which is tier 0 storage, maybe, with remote replication. Just an example. And Gold, Silver, whatever type of storage you want, right? RAID level or replication or what kind of, any sort of catalog you can define. Then comes policies. These are the constraints. So these are the constraints the storage admins will define, and I will go over the examples of those, as well as the attributes. You want thin volumes, you want compressed volumes, things like that, encrypted volumes. So in order to implement these policies, what we use is something called driver filter, if you are aware of that. This is a filter scheduler available in OpenStack, in Cinder. And we use extensively that thing. And as far as server administrators know, they don't know anything about storage details. All they know is the service catalogs, which are just the volume type and their description. So this is one example, a couple of examples here. I want to use pool P1 if it is less than 90%. So you see the last line there, filter function, which is basically saying that the allocated capacity should be less than 90% of total capacity. A simple example. If you go to the second example, I want to use pool P2 only if it is less than 125% over allocated. So in this case, we use provision capacity less than 1.25 times of the total capacity. So this is basically thin provisioning. So these are simple examples. This is a more interesting example where a customer wants to use it this way. So let's say we have a volume type silver 1, and this volume type is using pool P3. And what this customer wants is that I want to use this volume type, this pool, but if the requested volume is less than 500 gig, it should simply be a thin volume. If the requested volume size is greater than 500 gig, I want it to be a compressed volume. So this is the example. On the left, you see is basically on the last line there, you see volume.size is less than 500. That's basically is telling that use this. In CinderConf, you will have two backends defined, one with this on the left side configuration and the one with right side configuration. And with the left side, it's saying that if the size is less than 500 gig, use this config, meaning that create thin volume. And on the right side, you see that if the size is greater than 500 gig, then create a create a thin volume as well as a compressed volume. So this is we never thought of that. People would do something like this, but this is another example. And very important, replication. We know Cinder is going back and forth on replication, but we have to implement. The customers need it. So fortunately, I think with Cheesecake specifications, it's somewhat in good shape now. And we did have a SVC replication implemented. So this is the configuration example. It's not easy for storage admins to set it up like this. It's quite complicated. So it's something we have to look and probably will discuss in Design Summit, that how we improve this replication configuration setup. But this is basically, you're defining your target storage device and which pool to use on the target for this particular volume type. There are a bunch of other things we have used which are not yet there in Cinder or Horizon. For example, private volume types. It's very useful. It's there in Cinder CLI, at least as of Mitaka. It is not there in Horizon, but that's something very useful if you want to do access control on who can use which volume type by tenant. A very important thing is the volume naming. I didn't know that people depend on volume names so much. And in some cases, even the billing happens based on the volume name. So the storage admins want total control on the naming of the volume. And they don't want actually to specify the volume name. They want it to be automatically generated based on some template. So that's something we have implemented. Another thing which Cinder does, which is very useful, is fiber channel zoning. There are a bunch of customers still using fiber channel. And it does it all under the covers. We don't know about it. What the storage admins want is that I want to see what is being created, what zones are being created. So that's something we have done. We display the zoning configuration as well as what they want is that the zone names should not be just by some prefix. They should be template based like the storage volume names. So that's something also we have done. Another important thing is that you have to, in Cinder, you have to first create the volume, let it finish, and then you attach it. They want all together, create and attach together. So I will give you a host, give me 100 gig volume on this host. Replication I already talked about, and consistency group for replication, that's something very important, which is missing right now. One another important thing is that they want to actually create volume, assign volume at a specific time or in a specific window, not right now on demand. So that is a kind of a scheduled task feature. A very important thing is delete. Delete causes a lot of problems in a lot of customer environments. So what they want is that when I say delete, do not delete right away. Put it in pending delete state. And if there is no I/O happening on the volume, then delete it after X hours or whatever. That's configurable. So that is a very important feature which we have implemented. And very basic thing is that in CinderConf, you have clear text passwords. Nobody likes it. Very basic thing. We have to fix that. And right now, you have to define policies, and something goes in volume backend extra specs, something goes in CinderConf backend section. We need something very simple, which you define the policies in one place, attach it to volume type. Something like that we want, and hopefully we can discuss that during the design summit. So we have done all these things. Hopefully we can contribute some of it if the design gets approved. So basically, we are able to achieve these results. We have a much better operational efficiency now with agility, and the outages have been reduced because of zoning thing and the volume delete issues taken care. And given that this is now all managed by OpenStack, this opens door for hybrid, meaning that from traditional data center, you can actually move to public cloud if you need to, and manage those together. So that's all. I will be happy to take any questions after.